In this question, we have a copper cable with a given length and cross-sectional area, and it is suspending a 4,000 kilogram container, and we have to figure out how much the cable is going to stretch. And we have clipped a picture from the textbook and shown the inherent concept related to this question. And basically what we have is a force that is being exerted on one end of a cable, although in this picture it looks like it's more of a rod. But regardless, we have a force pulling on a structure, and of course the length of that structure is going to change, usually by a very small amount. And our job is, of course, to figure out how much that change in length will be. We just need a few different values because we can actually calculate the change in length according to the equation given below. And let's make sure we have all the requisite values though. So we're going to begin by needing the force that is being exerted on the cable. Well, let's recall that a 4,000 kilogram container was being suspended by the cable. So the gravitational force exerted on that container will also be exerted on the cable. And therefore, when it comes time to computing the force, we're actually going to use the gravitational force of the container. So it might be best if we put that in right here. We recall from earlier chapters that the force is actually mg. So we have that force. We also need the cross-sectional area of the cable, and that was given to us directly right here. And it's already in a standard unit of meters squared, so that's fairly convenient. We have y, which stands for the Young's modulus, and look at that, they gave us that value as well in standard unit form. The original length will also be needed, and that was given in standard form. That's 27 meters. And then again, our goal is to determine this change in length. So we indeed have every value we need. We just need to algebraically manipulate this equation. Let's multiply both sides by the original length. And maybe extend this little fraction here. So then the original lengths will cancel out on the right-hand side. And then we are left with y times delta L. We'll divide both sides of the equation by y. Over on this side, when you divide by y, it's going to end up in the denominator. So now we can see that the change in length is equal to the quantity at the left. We'll go ahead and plug in all the known values at this point. And so we've entered in all the values. Enter that into your calculator very carefully. And when you do so, you're going to get a value of 0.00476. We used all standard values and we're solving for a change in length, so that should come out to meters, and that is indeed the correct answer to the question.